data were collected from randomly selected samples to determine the relationship between average assignment score and test score in statistics distribution of the data presented in table below. So you have to derive the predicted equation. The second question is test the hypothesis for the regression model as the alpha is equal to 0.05. Determine the correlation coefficient and the multiple correlation coefficient means that R square and also the big R, interpret the two values and test hypothesis of the slope at the point level of significance 0.05. How to do that? Go to analyze and then go proceed to the regression and then proceed with the linear. Okay, analyze, proceed with the regression and then proceed with the linear. In this particular linear, you can enter the y as your dependent and please enter your x1 into the independent and your x2 in your independence also. When you enter these two things, then what will derive and what will occur after this is actually you hit the OK button. If you hit the OK button, straight away the SPSS will give you the idea of your regression model. But if you want to make some adjustment, you can do that according to this particular radio button, which is I may not able to discuss it today, but I will discuss it if you ask lah. And then you can go for the OK button. After you hit the OK button, these particular output are going to be generated for you. And then I'm going to export this one. Okay. So you go to the file, export, and then I'm going to export it. And then automatically, this is what I got from my output. So we are going to explain it together. Okay, the first one, I want to ask you. What is the first question? The first question, derive prediction equation. How you want to derive? You wait for me. That is one of the way lah. You wait for me until I give it to you, then you got it lah. Or you do it yourself. Okay, never mind. We do it together, Okay. Derive the equation. Can you derive it? Y is equal to? Wow, very good lah, very clever lah. How you know? You're so clever lah. Oh, very good lah. So your y it's equal to, not y lah, I mean y hat lah, means that predicted y is actually equal to this one. So you have to look into your this one. Yeah, your constant coefficient 1.969. So it's actually to be like this. Y is equal 1.969 plus 2.625 x1 plus 1.446 x2. That means this one is assignment x1, which is assignment 1. This one is assignment x2, which is assignment 2. So you got the marks of assignment 1, you plus with the assignment 2, and then you plus with this particular intercept, then you will get the predicted y, which is the possible score for your final marks. Okay, the first one is already khalas. Means what? We already construct this one. Selesai, Finish. Okay, the second question. Test hypothesis for the regression model at the alpha is 0.05. What is your null? Model is not fit. Very good. So your alternative will be model is fit. As simple as that. Okay. So the second step will be your alpha, and then your third step will be your run and analysis. Of course, you run it and then you report which value that you are looking at. You are looking at the ANOVA table, which is 8.6. Please help me. Which is your value will be what? Your ANOVA, which is your F statistics. F stat, it's 8.625, and then your P value. What is your P value, ladies and gentlemen? 0.005, right? That means you reject the null, and when you reject the null, you are going to make a conclusion. The model is fit, right? The model is fit. As simple as that. Okay, the third question. Determine the coefficients of determinations and multiple correlation coefficients. That means they require the R and also R square. So what is your R? Your R will be this one, 0.768. So this is your value for the R, 0.768, and then your R square will be 0.590. So it's equivalent to 59.0%, which is, for me, is fairly justified, which is you have the x1 and x2 combined together can explain 59% of the variance to predict this particular y. So it's fairly, I'm not saying good, but I say fairly explain this particular y, because there are so many uncertainties behind this particular example, right? And then the last but not least is actually you want to test for the slope. What is our null? What is our null? If you forgot to tell about what is the null, don't worry, you can go back to our notes and refer it. Okay, this is our example. What is our slope? This is our slope, right? There is no significant relationship between IV and DV, or no significant contributors of the X towards Y. So null will be no, there is no significant contribution of X for the Y, and also you inverse it. So the alternative will be there is significant contributions of the X towards Y. So now let's look into our data. So which one is significantly predicted? So we have the X1 can predict, yes, because the value is less than 0.05. What about the X2? The X2 is more than 0.05. That means only one predictor is functioning here. Therefore, you have to make the conclusion like this. So the conclusion will be the X1 significantly predict the Y. Okay, predict the Y. And then another one, which is the X2 is not able to predict the Y. Okay, that is what we call it as the slope hypothesis. So after you finish that one, if you want to make a revision during your free time later on in your organization, you can just refer back to our notes here, and then you can see it accordingly lah. This is the example. So when you go back to your organizations, then you can see this is our prediction equation. Similarly, like what we did just now. And then we can also go to the regression model. We can say that a regression model fits the data. And then we can say that 59% of the variance of the job satisfaction is already explained. Actually, it's not job satisfaction. It's what? Is the test lah. Test. It's not talking about the job satisfaction actually. It's different data. And then you can see here, since the significant T 0.03 is more than alpha, fail to reject the null, conclude that benefit of X2 does not contribute to contribution really. I'm so sorry. This data should not be like this. Actually, we talk about the X1 and X2. X1 is our test. So you conclude one X is significantly contribute and another X is not significantly contributes. You understand or not? This one. You can see the X1, which is the assignment test 1, is significantly contribute, and the assignment X2, which is the test 2, is not significantly contributes. So finish about our story in terms of the regression linear. So if you want to justify your data in your scientific notation, this is what you should conduct. This is what you should do. Your regression equation, and then you should explain your R and R square, and then you should explain your regression model, whether it's fit or not, and then you should also explain about your slope. And then in the simplified version, in your tabulation of data analysis, let's say you want to present it in your scientific paper or scientific conference. So this is the way of doing things. You have to report the B, the beta, the P. The B small is actually the unstandardized beta. This one is unstandardized beta. This one is beta. This one is P. So you have to use the coefficient table. This one. Based on the coefficient table, you got the B, which is the B small. This one is B. Actually, it's B small lah, unstandardized coefficient. And then this one is standardized beta. Okay. Let me explain a little bit what is the difference between unstandardized coefficient and standardized coefficient. Remember, ladies and gentlemen, in this model example, X1 is score test 1. Correct or not? X2 is score test 2. Correct? So you have the unstandardized coefficient. And suddenly, you also curious, why the SPSS give you standardized coefficient? Standardized coefficient is actually standardizing the element of X1 to be read together with the X2. Because this one, no issue, because X1 and X2 is the score. But can you think much more further? If let's say X1 is not the score, X1 is body weight. You measure body weight in what? Kilogram, right? X2, example, you measure your height. You measure your height using the meter or kilometer, centimeter. So if you want to read it on the standardized, on the unstandardized, of course it's not fair because the unstandardized talking about the standard deviation of that particular weight and height. It's different measurement, right? But if you look into the standardized coefficient, that is why the standardized coefficient exists, to make the justification, to make it standardized, because you got the weight in kilogram, now it's already being read as the standardized version of that. So this is the value of the standardized version of the weight, and then the height also is become standardized for this particular value. Do you understand? Don't understand. Okay, macam gini. Kenapa kita ada unstandardized? Sebab unstandardized adalah untuk raw data. Macam ni lah raw. Score 1, score 2. Tapi you bayangkan sekarang ni X1 and X2 sebab dia score. Cuba you bayangkan X1 dengan X2. X1 is berat. X2 is height. Apa maksud dia? X1 adalah berat dalam kilo. Height dalam meter. So, dia ada beza tak? Of course lah ada beza. Sebab itu you tak boleh baca, kalau you nak buat comparison, you tak boleh baca pada unstandardized. Sebab unstandardized untuk dibuat equation. Untuk you buat comparison between your study and different study, between your variable inside the another variable, you must use the standardized coefficient. Faham tak? Sebab standardized coefficient is already being standardized with regard of their units. Faham tak? Unstandardized, not regard the unit. Tapi standardized is already being standardized it according to the holistic unit. That means you can read it manually. So if you want to interpret, you can interpret is either using unstandardized and standardized. Tetapi remember in mind lah, kalau you interpret based on unstandardized, maknanya you tak pertikaikan pun soal dia punya raw unit. Tapi you want to talk it about the similar unit, you tak boleh talk dalam nilai 2.625. Sebab 2.625 tu adalah dalam kilo. Of the standard deviation dalam kilo. 1.446 adalah dalam meter. So, benda tu tak sama. Tapi you nak talk about the similarity, you talk using the standardized coefficient. The value of 0.576 standardized coefficient for height. 0.258 standardized coefficient for weight. Kan dia different tu. Where is the function used? When you want to compare your study with the different study. Itu additional. Kalau you nak compare your study dengan different people punya study, you compare yang standardized. Yes, sebab standardized, dia dah standardkan by the standard manner of calculation. That mean, you tak akan nampak nanti height tu tiba-tiba, you akan dapat unstandardized height mungkin 14.652. Betul tak? Ini contoh score. Sebab dia simple, kecil. Tapi kalau yang besar punya data, you akan dapat sampai negatif pun ada. Kan tak sama? Ada sekejap negatif, ada sekejap positif. So, how you want to justify if you want to compare with the previous study? Or the other study? You want to discuss it? You cannot. So, therefore, the SPSS give you the standardized coefficient so that you can make a standardized argument with your friend's paper, with your colleague paper in your body of knowledge. That is the idea.
Jadi unstandardized ni boleh kita panggil dekat raw.
Yes, unstandardized is used for the raw PE, predicted equation. But if you want to make a comparison, you never compare your predicted equation with your colleague because your unit might be different. You using kilometer, the other friend using miles. So how to make it comparable? You use the standardized coefficient to make a standardized equation. Yes.
Standardized coefficient only relates to the same period of time.
Correct.
As to when it's.
Yes, when it's happening to this particular data set. Correct. And that is the disclaimer that you also must bear in mind. If you run this particular linear regression, you no longer talk about the temporal things. You know temporal? Timing. You just assume it will be behave also like this when our friend in other countries also do like what we did. Okay, that assumption must be bear in mind lah, of course. But if you talk about the differences because of the time and so on, it is much more complex model lah. As for now, do you understand or not?